Assalamualaikum and hi. My name is Imran and in this slide, I will be explaining about the introduction part of our project. I will start with the definition of bearing. So, what is bearing? A bearing is a machine element that constrains relative motions and used to reduce the friction between moving parts. For an example, application of bearing on a sliding door. A door cannot be lifted or removed from its place, and the possible movement is restricted to sliding motion by bearing. They are easier to move, and when friction is reduced, speed and efficiency of an object will be enhanced. So, what is the function of bearing? The main purpose of bearing is to prevent direct metal-to-metal contact between two elements that are in relative motion. This prevents friction, heat generation, and ultimately the wear and tear of parts. It also reduces energy consumption as sliding motion is replaced with the low friction rolling. Besides, they also transmit the load of rotating element to the housing. The loads could be radial load, axial load, or the combination of both. Next, we will talk about truss bearing. There is different type of bearing used, and for this project, we are focusing on the truss bearing. The main purpose of truss bearing is mainly to accommodate axial load. It supports the axial thrust of both horizontal and vertical shaft. Besides, the function of truss bearing are to prevent the shaft from drifting in the axial direction and to transfer thrust load applied on the shaft. Next, in this project, we will look into the influence of oil viscosity grade on truss bearing. The performance of a truss bearing can be best quantified in terms of developed power loss, operating temperature, and oil film thickness. These parameters are all affected by oil viscosity. Normally, thinner oil provides lower energy consumption and lower operating temperature. There are three types of oil used in this project, which are SAE50, SAE20W40, and SAE15W40. The properties of this oil will be discussed by my friend in the discussion part.
Before starting our analysis, we need to have a few of our critical parameters fixed. They are the velocity, the length, the width of bearing, and the shoulder height. Then, we can proceed with the first step in which determining the dimensionless film thickness. For the sample calculation, we assume that the dimension film thickness is 10 micrometer, in which we obtain the dimensionless film thickness of HO equals 1. The second step is for us to obtain the dimensionless load capacity. Using the dimensionless film thickness obtained earlier, we substitute into the formula, hence we obtain the dimensionless load capacity shown on the screen. Now we have come to the third and the last part of the calculation. We have to determine the oil for this step, and here we use SAE50 oil at 40 degrees Celsius. Hence, we obtain the viscosity at the given temperature. Using the previously obtained values, with the viscosity we have, we substitute the values and we obtain the dimension load capacity. All the calculation steps are done using MATLAB with different film thickness on different oils. That's all from me, and we will proceed with the MATLAB analysis by my friend.
Hi, Assalamualaikum and a very good day. So my name is Muhammad Nazmi bin Adukam Mutmin. So in this project, we will be use MATLAB as a software that we use in order to plot the graph of the dimension load capacity against the minimum film thickness. From the journal that we review, stated that when the minimum film thickness approaching to infinity, so the dimension load capacity will be approaching to zero. So as you can see on the screen, the MATLAB coding, these are the parameters and assumption that we've made in order to find the dimension load capacity. So we chose three different of viscosity of the oil. So we have one monograde oil and two multi-grade oils. So what is the difference between these two oils is that the multi-grade oils will keep the viscosity at optimum level within the temperature range, but the monograde oil, as the temperature decreases, the oil will be get thickened. So before I forget, the SEE oil is the code of specifying the viscosity of the lubricating oils that used in the automotive. So we have three formula in sequence that in order to find the dimensional capacity. So the first one is the film thickness dimensionless term. The second one is dimensionless load capacity, and of course the third one is the dimension load capacity. So as you can see on the screen, the MATLAB coding, these are the calculation of dimensionless and dimensional capacity based on the three difference of the viscosity as AE oil. So the result of the graph plotted will be explained by my members. So that's all for me for the MATLAB coding. I thank you and see you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil bin Mawasli. So I would like to proceed with the discussion part. So in this study, we have set all the length, width, bearing velocity, and shoulder height to be fixed. The reason is we want to simplify the calculation. So that's why we have set all these parameters to be constant. So from this table, we have set the length to be 0.5 meter, the width 0.2 meter, bearing velocity with 10 meter per second, shoulder height 0.00001 meter. So beside this table, you can see the picture of the bearing. Okay, so before we move further, I would like to give a little brief about the type of oil that we use. Okay, so in this study, we want to analyze the load capacity for different type of oils. Therefore, we use three type of oil, which is SAE, which is SAE 50, SAE 20W40, and SAE 15W40. So these three type of oils consist of different value of viscosity. So we can see in the table the viscosity for every type of oil. Okay, so now we will proceed to the discussion of the graph. So from the graph of load capacity and gas medium film thickness, there are three graphs have been plotted. So the graph can be seen in the figure above. So from this graph, we can see that the load capacity is inversely proportional to the minimum film thickness. So that means that when the minimum film thickness is increased, the load capacity will be decreased. So we have noticed that as the minimum film thickness is increased, so the load capacity for all type of oil will come closer to each other. So in this study, the SAE 50 recorded the highest load capacity, which is 160,261 Newton when the minimum film thickness of 10 micrometer is used. At this point, we also record that the lowest load capacity from SAE 15W40, which is 85,796.9 Newton when the minimum film thickness is also 10 micrometer. Okay, so now I will pass to Zarek. Thank you.
Assalamualaikum. My name is Muhammad Zara Ashraf Yusri, and I will talk about the discussion, which is the continuation from Muhammad Shami. So from the graph of load capacity against minimum flame thickness, we can see that when the minimum flame thickness is increased to 100 micrometer. The SAE 50 oil with 0.00204 Pascal dot second shows the highest value of load capacity with 441.158 Newton when compared to other type of oil. On the other hand, the SAE 15W40 oil with viscosity of 0.00108 Pascal dot second shows the lowest load capacity, which is 233.554 Newton. Uh, when the minimum fluid thickness reaches the highest value in this study with 200 micrometer, the load capacity will decrease to the lowest value. At this value of minimum fluid thickness, the SAE 50 oil with 0.00204 Pascal dot seconds indicates the highest load capacity with 59.219 Newton. Same as before, the lowest load capacity can be identified to be SEE 15W40 oil with a viscosity of 0.00108 Pascal dot second with 31.251 Newton of load capacity. So from the graph, we can observe that the oil viscosity has a direct impact on the load capacity of the bearing. High viscosity oil provides better lubrication and film thickness, which helps to increase the load capacity of the bearing. On the other hand, low viscosity oils may have not provided adequate lubrication, and this can result in increased friction and wear on the bearing, which will end up reducing the bearing's load capacity. However, this is only applicable in our study, as we only observe the effect of oil viscosity on the load capacity, which we do not consider other effects such as temperature rise and power loss. This is because if the viscosity of the oil is too high, the oil may not transfer the heat well, which will cause the temperature to increase and end up bringing power loss to the bearing. That is all from me. Thank you.
Lastly, as a conclusion, a truss bearing with different minimum film thickness to the load capacity thus influenced by the viscosity of the oil. It follows from the carried out calculations and their graphic representations that both magnitudes are dependent on the value of the oil viscosity. The relationship between the minimum film thickness and the load capacity was numerically confirmed that they were inversely proportional. A higher magnitude of oil viscosity will lead to a greater load capacity. Based on three types of oil used in this project, the load capacity generated by the SAE50, SAE20W40, and SAE15W40 were found to be 162.0601 kN, 109.6293 kN, and 85.7968 kN respectively. Furthermore, based on this project, we learned that the lubrication plays a major role for a bearing to achieve a stable and smooth rotation. It is important to choose the appropriate lubricant to enable the bearing to rotate and operate stably over a long period of time. That is all from us. Thank you.